Hello everyone and welcome to my video tutorial on Introduction to Computer Programming using Python. This is class 07 of a series, Control Structures Part 1, Conditional Statements. The objective of the class today is to learn about conditional statement control structures in Python. Motivation. Control structures are fundamental to any programming language, to the concept of programming and to life itself. Life is about having control over things, and so it is with computer software. It is control that gives logical behavior to a computer, so it is essential for the aspiring programmer in any language to understand and master control structures. So what we are going to learn in this class today, it's not just about Python alone. If you learn any other programming language, Java, C, C++, JavaScript, you must encounter control structures. And basically the idea will be the same for all of them. So the knowledge you get from this class can be carried on to any other programming languages that you will learn in the future. At the end of this class, participants should be able to explain what control structures are and explain their importance in programming in general. Describe the various forms of if control statements. Write Python programs to create if control statements and to perform various operations with them. Content. Introduction to control structures. Introduction to conditional statements. Conditional statements if else, if else, conditional checks, checking multiple conditions, checking lists, using multiple lists, and finally we'll have a homework. So, what are control structures in programming? They are commands that enable a program to make decisions and take alternative courses of action based on some conditions and parameter values. They can also enable a section of a program to execute repeatedly based on some conditions and parameter values. Types of control structures. Conditionals or selection structures / statements. They are used to execute one or more statements if a condition is met or certain conditions are met. Loops or iteration control structures or statements are used to repeat a statement a certain number of times while a condition is fulfilled. So the first one, called conditionals, is to make a decision between alternative courses of action, while the second one is for repeated operations. When there are operations that need to be repeated, you use a loop. So those are the two basic types of control structures in most programming languages, including Python. So today we will learn about conditional statements, while the loop control structures will be taken in part 2 of the course. Conditional statements are core concepts in programming. Generally, they model everyday logical entity. They also form the basis for the logical capability of a program or software. So let me explain it this way. Life is based on decisions. Somebody decides to wake up in the morning for a reason. Maybe you set the alarm, and then you have a schedule for the day, what you are going to do in the day. All of them are based on choices that you make depending if certain conditions are met. That's the way somebody lives his life logically. So when people say a program or a software or the computer in general behaves like an intelligent machine, a smart machine, or a machine that can make decisions, it is because computer programmers actually designed the software to behave like that. So one of the ways to make the machine behave logically is to use these conditional statements. Generally, each conditional statement has something called a syntax. Syntax is the right way it is used, and it can be of several types. The if statement is a conditional statement. Then we have a more complex form of it, which is the if else statement. Then we have the if then else statement, and we'll look at them one by one. So if we start with the simplest conditional statement, which is the if, what it does is execute a code or a sequence of codes if a condition is true. The syntax is, if a condition is true, execute an indented statement and continue executing the sequence of indented statements. It behaves like this. I'm going to show a diagram now, a flowchart that describes the way the if structure behaves. So we start, and then we'll move along the program. We test a condition. If the condition is true, execute a statement, and then we are going towards the end of the program after the statement has been executed. If the condition is false, don't execute anything, just go to the end of the program. So we see an example. We'll call it if test.py to demonstrate the if statement in Python, a basic if. So we'll clear the console as usual. If you still remember the very first program with which we started the Python course in the very first class, it was a guessing game. So we say G equal to impute guess the number. Type a number on the keypad, and then we'll convert the number to an integer variable. We'll call it guess to accept whatever number a person is going to type from the keyboard. So we use it in an if statement. So we said if guess equal to 5, if the number typed by the user was 5, print a message, you win. Print another message, we are still in the if statement because of the indent, and print another message, no longer in the if statement because we are out of the indent. So if we take a closer look at what we have here, we have the if, and then we have the conditional test. If guess equal to 5, which is realized by using this double equal to. At the end of the if statement is a colon which denotes the end of the if condition. Everything that is indented thereafter is the sequence of codes that will be executed under this if condition. So first thing, we printed the value. Whatever else you type under it that is indented is going to be executed. The moment you type any other code that is outside the indent, we are out of the if statement. So the if statement began from here and ended at this point, where there are indented items or indented lines of code. So that is exactly how the basic if statement works in Python. If you run the program, this is how it's going to look like. Now recall that whenever you are writing a Python program in which a user needs to type something at the keypad, you cannot use AREPL to show the output. Rather, you have to do the typing, show the output in a Python terminal console. So I am going to leave this window now so that we can go and run the program in Python and see the way it behaves. Already by now you should have known how to open your code directory folder inside Visual Studio Code. If you don't know how to do that, go and watch the video before the last one. So what we are trying to do is if test, which is the most basic test, the most basic control structure if conditional statement in Python. And this is how our program look like. Now if you look at this Visual Studio window, the terminal is not open. You don't need to open the terminal. If you just click run, you will see the output of the program. So I have already explained each of the codes line by line, so we'll just run it and see how it looks like. So I click the run button there, and it says guess the number. If we type 5 and press enter, it's going to print you win, because what we typed was 5. So this was the first output. It printed you win, which is what we have here. And then it also printed we are still in the if statement because of the indent, which is what was printed here. And finally, when it was out of the if statement, it printed this last one, which is what is printed here. So let's try running the program with another value that is not 5. So let's say we put 4 or 6. If we type 4, it's going to say no longer in the if statement because we're out of the indent. So the if condition only executes when our guess is equal to 5. If you type any number that is not 5, the if condition does not execute at all. So it goes straight to the print statement, which is the last statement of the program that is not a part of the if. So that's why I printed the value that I have here. And this is what you are going to get if you type any other value that is not 5. Let's say we type 7. Okay, so this is simple enough. Now, the next conditional statement that we are going to look at is the if else. We are making it a little bit more complicated. So the if else statement executes a code or a sequence of codes if a condition is true. Otherwise, it executes another statement if the condition is false. The syntax is: if a condition is true, execute this statement, continue executing the sequence of indented statements. Otherwise, if the condition is not true, execute another statement, continue executing the sequence of indented statements. So the flowchart looks like this. We start, then we test the condition. If the condition is true, we execute a statement or a sequence of statements. If the condition is false, we also execute another statement or a sequence of statements before we finally go to the end of the program. If else test example program. We are now extending the very first program, so we say G equal to impute, guess the number, type a number, convert it to an integer. If guess equal to 5, print you win. Print we are still in the if statement because of the indent. The alternative course of action comes here. Else, if you type any number that is not equal to 5, print you lose. We are still in the else statement because of the indent. Finally, we get out of the indent. We are no longer in the if else statement because we are out of the indent. Now, if you run the program, this is what the output is going to look like. So we'll go now to see the Python example. Let's close this. If else test. Run the program. First thing we are going to do is type 5. The output is you win. We are still in the if statement because of the indent. So you see, the first part executed this line of this sequence of codes, the if part of the statement, and then after executing it, it came to print the last item, which we are seeing here. This part was not executed because what we typed was 5. So you can see the alternative courses of action. Every time you type a number that is not 5, it is this code that is going to be executed. Every time you type a number that is 5, it is this code that is going to be executed. So we'll run the program again and type a number that is not 5. So let's type, say, 6. You lose. We are still in the else statement because of the indent. And then finally, when it is out of the conditional statement, it prints the final code in the program. Okay, so let's look at a more complicated conditional statement. If else statement. The syntax: we are going to test multiple conditions. If a condition is true, we call it condition 1. Execute this statement. Continue executing the sequence of indented statements. Else, if a second condition is true, say condition 2, execute a statement, continue executing a sequence of indented statements, and continue that way up till the end condition. If condition n is true, execute this statement, continue executing the sequence of indented statements, and finally you can have an else. Else is if none of the conditions here from condition 1 to condition n is satisfied, you finally execute a final statement or a sequence of statements before the program ends. So we see another example. If elif else test. So we say guess the number, type a number, convert it to an integer. If guess is equal to 5, print you win. Continue execution. Otherwise, if guess is equal to 4, print you lose, but you are close. Continue executing. Otherwise, if the guess is equal to 9, print you lose and you are far off. Continue printing. Otherwise, if the number is not 5, the number is not 4, the number is not 9, then do something else. Print you lose and print something else before you finally get out of the control structure. So we see the code. Now we are going to test this code with 5, we will test it with 4, we will test it with 9, then we will test it with any other number that is not 5, 4 and 9 and see the different outputs that we get. Start with 5. You win. We are still in the if statement because of the indent. 4. You lose, but you are close. We are still in the elif statement because of the indent. So Python represent the else if with elif. It's just an abbreviation for else if in Python. So we run it again and put 9. Okay, now take note of this. If you are running a Python program in Visual Studio Code, don't select anything like this. If you select something, by the time you run it, it's going to give you an error because it is coming back here. You have to unselect anything before you run the program. So you run it again. First of all, let me type 9 and press enter. You lose and you are far off. Now let me select something and run the code again. See, it's going to give you an error. So make sure nothing is selected before you run the Python program. Okay, so let's look at conditional checks. There are more conditional statements that we can actually think about. If you still recall the comparison operations that we studied in class 04, they usually returned true or false result. So we'll look at several operators, their description, and the syntax that is used in executing them. There is the greater than operator, which is true if a variable x is greater than y and false otherwise. And the general syntax in Python is you just say x greater than y. There is also the less than, which is true if a variable x is less than a variable y and false otherwise. And the syntax is x less than y. There is a greater or equal to, which is true if a variable x is greater or equal to a variable y and false otherwise, the syntax is x greater or equal to y. The same way, less or equal to true, and the syntax is x less or equal to y. Then we have the equal to, which is the one we have actually been using more frequently. True if x and y are the same, and false otherwise. And finally we have the not equal to, which is true if variable x is not equal to y, false otherwise, and the syntax is x not equal to y. So we'll look at conditional checks in more details. Checking for inequalities. We could say if guess greater than 5. We could also say if guess less than 5. It's a conditional check. We could also say if guess greater or equal to 5, or if guess less or equal to 5. If car not equal to BMW. Now, checking for equality is something we've done more frequently in our programming practice so far. If guess equal to 5 means if a variable container called guess is truly equal to 5. That's the value inside the variable. Is it actually equal to 5? That's what we mean by this double equal to. Now, some students confuse the double equal to with a single equal to. Let's look at the difference. When you say guess equal to 5, it means you are actually putting the value of 5 into the variable guess. So at that moment the content of guess is 5. The difference between the single equal to and double equal to is, for double equal to you are asking, is the content of the variable guess actually equal to 5? Let's take this analogy. If you have a container for salt, for instance, that container is asking to guess. It's a variable. You can store any value inside it. Now, when you say the container equal to 5, it means you are actually taking something like 5 grams of salt and putting it inside the container. That is single equal to. So the container contains 5 grams of salt at that moment. Now, when you want to test, does the container actually contains 5 grams of salt? The double equal to is saying, does the container actually contains 5 grams of salt? That will be true or false. So that's the difference. Single equal to is you are assigning a value to the variable. Double equal to is you are testing whether the value in the variable is actually equal to whatever is on the right side. Now, when you are checking for equality with strings, there can be problems. For instance, if you assign the value of Audi to a variable called car, Audi with a capital A is not the same thing as Audi with a small letter A. So, if you go and test later whether the variable called car actually contains Audi with a small a, it will return false. How do you deal with such kind of situation? You use the built-in function lower. So if you say, instead of saying if car equal to Audi, you just say if car dot lower equal to Audi. It will return true. Whether the original value you put there was a capital A or a small a, it doesn't matter, it's going to return true. So that is how to deal with case when you are checking equality for strings. Now we'll see an example. Conditional check to demonstrate conditional checks in Python. So we say guess the number, type a number. We convert it to an integer. And then we can say if guess equal to 4, print your guess is 4. Elif, that is else if guess less than 4, print your guess is less than 4. Elif, guess greater or equal to 20, print your guess is greater or equal to 20. Else, if it is any number, print I cannot guess what you guessed. So you can actually estimate which numbers are going to be outside the range. First of all, we have 4. The program will recognize it. And then we have anything less than 4. That is from minus infinity to 3. That is for this. And then we have another range of numbers, 20 to infinity. Of course, Python is not going to take infinity, but let's just say we are moving from 20 to wherever we can go, depending on the precision of the computer. So which numbers are going to fall within this range of else? We are looking at 5 to 19. These are the numbers that are not going to be guessed, or your program cannot tell whatever was guessed. So we are going to go ahead and run this program. So here we are. Now in this code, we are going to test it with 4. Then we will test it with any number less than 4. Then we test it with any number greater or equal to 20. And then we test it with any number within the range of 5 to 19. And we see the various outputs. Enter 4. Press enter. Your guess is 4. That is good. Enter any number less than 4. Let's say 2. Your guess is less than 4. Enter any number greater or equal to 20. Your guess is greater or equal to 20. Now let's enter any number from the range of 5 to 20. Take 5. I cannot guess what you guessed. Take 19. I cannot guess what you guessed. So we are still looking at conditional checks. We talked about ignoring case when checking for equality using strings. So suppose we assign Toyota to the variable car, and then we want to test, is car equal to Toyota? This is going to return a true or false value. It will return a false, because we are using a small letter Toyota while we assign the capital letter T to car. We are using a small letter T for Toyota to check. So how do we resolve that problem? We just say car.lower equal to Toyota. This will now return a true. And if you run the program, this is what it's going to look like. Now that we don't need to enter any input before we get the output, we can just use arrayPL to check our output. So if I come here and edit, it just gives you the output here. Car equal to Toyota, false. Car.lower equal to Toyota, true. You can as well run the program and see the output in the console. It's the same thing with what you get with arrayPL. Now let's see how to check multiple conditions in Python. We can use AND to check for multiple conditions. If we say if guess greater than 5 and guess less than 9, we are saying that the value of guess should be from 6 upwards and the value of guess must be less than 9. So that will be 6, 7, 8. We can also say if guess greater or equal to 5 and age less or equal to 9, in which case we are dealing with two different variables. One of them is guess and the other one is age, and both of them must conform. Either guess must be greater or equal to 5 and age must be less or equal to 9. In fact, this test will only be true if both conditions are true. If guess is greater than or equal to 5 and must age less or equal to 9. We can also say if guess equal to 5 and age less or equal to 9. We can also say if car equal to BMW and color equal to ash. For and conditions, both multiple conditions must be true in order for the whole condition to be true. On the other hand, we can use an or. If guess greater than 5 or guess less than 9. Now take note, when you are using or for multiple conditions in Python, you have to be very careful because the statement can be illogical. We will see this in an example. If we say if guess greater than 5 or guess less than 9, because only one condition makes it true. If either one of them is true, either this is true or this is true, everything is true. It's not like and where both of them must be true. So if I say guess greater or equal to 5, I am saying any number from 6 to infinity is true. And if I say or guess less than 9, I am saying any number from 8 to minus infinity is true. So that's the reason why this statement is illogical, which means that every number at all will be evaluated to true with this condition. Now let's look at something more logical. We can say if guess equal to 5 or age less or equal to 15, any one of them can be true. If guess equal to 5, it is already true. You don't need to evaluate the age. If age less or equal to 15, it is already true. You don't need to evaluate the guess. We can also say if guess equal to 5 or age greater than 15 and age less than 20. That is, age is within the range 15 to 20 or guess equal to 5. Now any one of them that is true makes the whole condition true. We can also say if guess equal to 6 or age greater or equal to 20 and age less than 40. Any one of them can be true. And it makes the whole condition true. We can also say if car brand equal to Toyota or car class equal to Corolla. So if somebody enters Toyota, it's already true. They don't need to enter Corolla. If somebody enters Corolla, it is already true. They don't need to enter Toyota. That is all. Any one of both conditions makes it true. That is why it is all. Let's see an example. If multiple conditions 1.py. So we are expanding our very first program. Now we are going to take two inputs from the keyboard and see the way the syntax goes. We say G, A. In fact, you can accept as many inputs as possible from the keyboard in Python. We want to accept two inputs in this case. So what you do is you just put all the variables here and then you say input, and after the input you put a dot and it says split. So this split is what breaks down whatever the users type in the keyboard into the several variables that are meant to be accepted. So we say guess, variable guess which we created equal to int G, and we say variable age equal to int A. So we want to now check for multiple conditions. If guess greater than 5 and guess less than 9, print your guess is between 6 and 8. Elif, guess greater or equal to 9 and guess less than equal to 15, print your guess is within 9 and 15. That is 9 is inclusive, 15 is inclusive. Take note that for the first one 5 is not inclusive because it must be greater than 5, and 9 is not inclusive because it must be less than 9. So you have 6, 7, 8. In the second one you have 9, 10, 11, 12, 13, 14, 15. Elif, guess equal to 17 and age less than 19, print your guess is 17 and you are less than 19 years old. Else, any other choice outside what we have listed here, print I cannot guess what you entered. So let's look at this program again. In the first if we are using guess and guess. In the second if we are using guess and guess. And in the third if we are using guess and age. So you can combine them together like that in your statement. So when we run the program, this is what it looks like. So in running this program, we are going to take a choice of something between 5 and 9. Then we take a choice of something between 9 and 15. And then we take another choice of 17 and something below 19. So let's run it. 6. So since 2 inputs are expected, you type the first input, you press the space bar, and then you type the second input. Your guess is between 6 and 8. We'll run it again. Second one, let's take 9 and let's take 14. Your guess is within 9 and 15, 9 inclusive. To test the third condition, guess must be 17, and let's take something less than 19, say 18. This is when we talk about age. Your guess is 17 and you are less than 19 years old. So let's see a condition that will not be identified by the system. Say we take 17 and we say 20. What do we get? I cannot guess what you entered. And that's what we have here. Okay, so we are still checking multiple conditions. Now let's look at the OR, which is a little bit more trickish. We call it multiple conditions 2. In the same way, we are going to receive our 2 inputs, guess and age. Let's check for multiple conditions. If guess greater than 5 or guess less than 9, this is very illogical, meaning that any number can be accepted, as we can see in our example. So we'll print any number goes. So let's try. If guess equal to 5 or age less than 15, any one of them can be true. Your guess is 5 or you are not more than 15 years old. L if guess equal to 5 or age greater than 15 and age less than 20. Now take note of this. As long as this condition is the same thing as this condition, the moment somebody enters 5, since this is the first code, this is what is going to be executed consistently as long as somebody takes 5, because only this condition needs to be true for the whole thing to be true, the whole logical statement to be true. So as long as somebody type 5 here, the program doesn't need to look at this side, rather it will execute the first code that has this same logical condition that this one has. If guess equal to 6 or age greater than 20 and age less than 40, the only time the program will look at this side of the code is when the user types 6 before typing any other number. Otherwise, I cannot guess what you entered. So if you run the program, this is what it's going to look like. So we see the code in Python. Now if we keep running this code in Python, no matter what we enter, this is the only thing that will keep printing out. We try it, because this statement is illogical, like we said before. If I type 5, or let's say I type 6, let's try to satisfy the first condition, and I type 8, any number goes, that's what it says. In the same way, if I type any number goes. So what we are going to do now is comment this illogical code out of the program and test parts of the code that are more logical. So we are left with 1, 2, 3 conditions and a 4th condition. So let's run the program again. We will now test 5 and 15. What do we get? Your guess is 5 and you are not more than 15 years old. If we run this program again, as long as you type 5 if you like, type 100. It's going to go back and tell you your guess is 5 or you are not more than 15 years old, because we already satisfied the first condition of 5. So this part of the code does not execute at all. As long as you are typing 5, it will not come here. So the only time it is going to look at another part of the code is when we type something that is not 5. 100. Your guess is 6 or you are more than 20 years old. Your guess is 6 or you are more than 20 years old. So it ignores any other part of the code because we have already typed 6. Now let's try something again. Suppose we type 7. We have not satisfied any of the first condition on this side. So if we type 7 100 and press enter, I cannot guess what you entered. Now let's continue by checking other multiple conditions, especially string conditions. So we'll call it multiple conditions 3. Car, color, input, enter the brand and color of your car. Dot split. If car.lower equal to BMW or car.lower equal to ash, print your car is either ash colored or it is a BMW. So if either one of them is true, the whole condition is true. Either you enter BMW or you enter ash, the condition will be true. Else car.lower equal to Ford and car.lower equal to black, both conditions must be true because it's an AND. Then you say your car is a black colored Ford. Otherwise, your car is neither ash colored nor black colored, nor is it a BMW or a Ford. When you run the program, this is what it looks like. So we start by entering, say, BMW yellow. Press enter. Your car is either ash colored or is a BMW. It evaluated to true because one of the conditions was true, which is a BMW which we entered. So we run the program again. This time around we enter Volvo and say ash. It will still evaluate to true because one of the conditions is true, which is ash. Your car is either ash colored or it is a BMW. Again, it is true. So suppose we say Volvo yellow. Press enter. Your car is neither ash stroke black colored nor is it a BMW stroke Ford. So the condition is this one was not true. This one was also not true. It was the else condition that was executed. Now let's run the program again and see if we can make the elif part to be true. So if we say Ford black, your car is a black colored Ford. So we'll continue with our conditional statements. This time around we want to make practical use of what we have been learning by using it to check lists. We have been making lists that are already populated with items inside the program code since we have been writing programs. However, in reality, many lists will be created as empty, and it is after the software has been deployed that users will begin to add data to populate the list. For example, when you create a software to accept customers, you don't know how many customers are coming to register. So you create an empty list, and when the customers begin to register, their data begin to populate the list that you have created. So it is therefore useful to check whether a list is empty or not, whether an item is in the list, and how many items are inside the list. Especially before running a for loop, you need to know whether a list is empty or not. If statement can be used to check whether a list is empty or not. We can also check whether a value is inside the list, a specific value. To do that, we use the in keyword. We can also check whether a value is not in a list. To do that, we use the not in keyword. So we see an example. Checking lists.py. To demonstrate checking of lists using if statement in Python. So we have a list of something like this: banned users. Suppose some users have been banned for using a specific app or software. I mean, these things happen frequently. Sometimes they say somebody has been banned from Twitter or something like that. So let's say we have a list: Andrew, Carolina, David. The list is not empty. We can check whether a value is in this list. So if we create a variable and call it Carolina, we want to know whether Carolina is in the list of banned users. So we say if user in banned users, print user.title, you cannot post a response. That's for example. We can also check whether a value is not in a list. So we say Marie, for instance. If user not in banned users, if Marie is not in the list of banned users, print, you can post a response if you wish. We can also check whether a list is not empty. So let's create an empty list. For instance, requested toppings is an empty list. If requested toppings, see, you check if a list is empty or not by just using an if statement. If requested toppings is going to return false. Why? Because the list is empty. If there was something in the list, if you say if requested toppings, is going to return true. So let's continue the statement, the if statement we are trying to construct here. If requested toppings, print requested toppings will be added. That is if there is something inside requested toppings. Otherwise, print no requested toppings. So you will see that what will be printed out of this program is no requested toppings, because there is nothing in the list. So if you run the program, that's what we get. So you can actually see it here, no requested toppings. So the program is checking lists. Since this program does not require you to enter something from the keyboard, we can use arraypl to see the output on this side of the screen. Once again, I am going to comment out some part of the code so that we can see how various segments of the codes are executing as we progress. So the first part, we created a list of banned users: Andrew, Carolina, David, and then we say user equal to Carolina. If user in banned users, print user.title, you cannot post a response, and this is the output we have here. Carolina, you cannot post a response. Why? Because Carolina is in the list of banned users. Let's move this a little bit lower and see the next printout. So we say user equal to Mary. If user not in banned users, print, you can post a response if you wish. So what do we get? Mary, you can post a response if you wish. If we move this further down, we have a multiple condition, if else. Requested toppings is an empty list, so what we are trying to actually test whether this list is empty or not, something inside it or not, and there is nothing inside it. And what do we get? No requested toppings. Now let's look at a more useful example of what we just did now, using multiple lists. To demonstrate using of multiple lists with if statements in Python, we create a list called available toppings, and then there are items inside it: mushrooms, olives, green peppers, pepperoni, pineapple, extra cheese. That's one list. And then we'll create a second list: requested toppings, mushrooms, french fries, extra cheese. This is reminiscent of a Pizza Hut or something like that, where they have a list of available toppings that are available for customers to request, and the requested toppings is something from a specific customer. What you do is you check the available toppings to see whether the requested toppings are available. The ones that are available will be added. The ones that are not available will not be added. So we create a for loop and say for requested topping in requested toppings. Take note of this. This requested topping here is just a variable. This is the real list, requested toppings, which is this list above here. So for everything in this list one by one, we are going to go through it and search for it in this available toppings list. So we say if requested topping is in available toppings list, then add it. We are adding requested topping. Otherwise, sorry, we don't have the requested topping. And that is all. So how many times is this loop going to run? In the first four, we say first thing we do is pick mushrooms. Then we check for mushrooms inside available toppings. If mushrooms is in available toppings, we add it. After adding it, we'll come back to the top of the loop to the for again the second time, and we pick french fries, and then we're going to look for it in available toppings. French fries is not available, so we'll go to the else and say sorry, we don't have french fries. Next thing is we pick extra cheese. Then we'll go to available toppings and look for it. Extra cheese is the last item. You add extra cheese, and by the time you have gone through this 1, 2, 3 items in requested toppings, you are done with the loop. And finally you print finish making your pizza. This is the output we get using multiple lists. So we open ARAPL as usual. And we modify something. Okay. First time we picked mushrooms, and mushrooms is in the available toppings, so the first time this loop is executed is you say adding mushrooms. The second time you come to french fries, and then you go through available toppings. French fries is not there, so the second time the loop is executed, you say sorry, we don't have french fries. Finally you come and take extra cheese, and then you go to available toppings and you are looking for extra cheese, and it is right here, and then you print adding extra cheese. The 3 items in requested toppings have been satisfied in this for loop, and finally you print finished making your pizza. That's the printout you have here. We have come to the end of the class today. Here's a homework lab for you in case you are interested. In the book of Eric Matthews' Python Crash Course, attempt the following. Try it yourself. Exercise 5.3, alien colors, number 1. Alien colors, number 2. Exercise 5.7, favorite fruit. Our bibliography, the main book still remains the book of Eric Matthews' Python Crash Course, and the rest of them. Please like, share, comment and subscribe for more videos. Thank you very much and see you in the next class.